Just when you thought smooth muscle contractions couldn't get any worse, it does. Alright, welcome back. In this video, we're going to go over MLCP. In the last video, we talked about how MLCK activates myosin heads and causes contraction to happen. But how do we actually inactivate myosin heads? How do we tell our muscles, our smooth muscles rather, to stop contracting and to relax, essentially? That's where MLCP comes in, also known as Myosin Light Chain Phosphatase. So in this very simple diagram here, we already went over what MLCK does in the last video. We said that, the ATP sheds off phosphate and it basically binds to the myosin head, charging it up, giving it an energy. What we didn't go over is MLCP. So backwards, it sheds off the phosphate and basically inactivates it. That's literally what MLCP is. But it's a little bit more complicated than that. And yeah. So smooth muscles relax. Basically no contraction through MLCP. But how does it actually happen? Beta-2 adrenergic receptors. Oh shit, I bet you were like, oh man, I thought we were done with this kind of stuff. Nope, it's back. Forever. For your life. It's back. Too bad. So it's beta-2 receptors. So we have to go over the G protein pathway for you to understand what's going on and how this actually has to do with MLCP. So this is the GS pathway. So the beta-2 adrenergic receptors use the GS pathway. I made a whole video about alpha and beta receptors, so please check that out. I'll also link it in the description. But this is going to use the GS pathway. That's what beta-2 uses. So G protein activates adenyl cyclase. Don't worry about all this green stuff. Yeah, just we're going to go over the pathway. Adenyl cyclase activates CAMP, which activates pKa, which causes phosphorylation and in a cell response. Okay? We really don't care about any of this. What we care about is the pKa part of it. This is what does everything regarding smooth muscle relaxation. So the first thing that pKa does, it basically inactivates MLCK. So what pKa does, let's go back to this original figure here, is that pKa basically tells MLCK to shut up. Stop doing what you're doing. That's what pKa does. Easy, right? It inhibits MLCK. What it also does, what pKa also does, is closes the sarcoplasmic reticulum so calcium cannot leave. So do you remember in our smooth muscle contraction video, we said that here's the sarcoplasmic reticulum. There's a bunch of calcium here. That's too thick. Okay. Right? And then there was, let's do this. Right. And we said that there's like a little gate here. Well, what this pKa does, it basically closes the gate. So no calcium can leave, right? It's not possible. That's literally what's happening. Because remember, the calcium is what's causing the smooth muscle to even contract. But if we don't have any calcium, it won't contract. So once again, the sarcoplasmic reticulum closes so this calcium cannot leave. What pKa also does is it activates voltage-gated potassium channels, so the membrane voltage goes down. Okay? So originally, well, in a cell, there's a high amount of potassium. And not much outside. High inside, low outside. So what we're going to do is we're going to activate these voltage-gated potassium channels. Wrong one. Okay. We're going to activate these voltage-gated potassium channels so that now they're open, and now potassium is going to go outside. And remember, the potassium is positively charged. So if positive stuff leaves inside the cell, the voltage will go down. If we started at negative 45, we're going to go down to, I don't know what, negative 80 or whatever. lowering the voltage. Because remember, how calcium leaves the sarcoplasmic reticulum is by voltage. But if we don't have that, if we don't have that necessary voltage to open the sarcoplasmic reticulum, it ain't gonna happen. So it activates voltage-gated potassium channels so the membrane voltage goes down. Lastly, PKA basically increases MLCP activity, so it shoots up. So we said that PKA inhibits this, like no more. PKA boosts this up. That's it. So basically, it kind of like activates more MLCP activity. That's what's happening. So this leads to no contraction whatsoever. Now, what about if you want contractions to happen in your smooth muscle? What do we do? Well, we use the alpha-1 receptors to do this. And once again, in that, like I mentioned, the alpha-1 video, it uses the GQ pathway. So let's go over that. So you got our G protein, which activates PLC. PLC does two different things. It activates DAG, which then activates PKC, phosphokinase C, and causes phosphorylation to happen. On the other hand, also, PLC also causes IP3 to activate inositol phosphate 3, triphosphate, which causes the calcium to be released from the sarcoplasmic reticulum, which causes contraction. Cool. But let's look at it more in depth. So let's look at what IP3 does first. So IP3 opens the sarcoplasmic reticulum, the channels in the sarcoplasmic reticulum, so calcium can leave. So we talked about this sarcoplasmic reticulum. We got calcium here. And what we're going to basically do is when IP3, wrong one. When IP3 is generated or made, this basically opens up and we got calcium to really be released. Okay, that's the first thing. The second thing is the calcium release from the sarcoplasmic reticulum causes MLCK activity to increase. So back in here, let's erase this stuff. So when calcium is released from the sarcoplasmic reticulum, here's our calcium, it's going to basically make MLCK, make more MLCK. So MLCK activity is going to jack up when calcium is exposed. That's it. And what can we learn? Well, how do we know this is going to happen? We actually answered this in a previous video. Do you remember the whole calcium calmodulin complex? This whole calmodulin, whatever, calcium calmodulin complex. And remember how we said that this activates MLCK? Well, if you have more calcium, we're going to get more MLCK activation. That's how it works. Okay. Now let's look at PKC now. PKC causes calcium from outside the cell to go inside the muscle cell. So you got our cell here. And then let's make a little gap here. Okay. So calcium is going to go inside. Let's pretend this is our muscle cell. Calcium is going to go inside. And this is our muscle cell. So that's what PKC does. PKC also inhibits MLCP activity. So remember, MLCP is what causes no contraction to happen. It relaxes the muscle. So we don't want this happening. Okay? So we're talking about PKC. So PKC is going to go over and basically tell MLCP to shut up, stop doing what you're doing. So now we're only left with MLCK. So we only go in one direction, this way. Okay? And all of this would cause a contraction to happen. So top half stuff, so all this stuff causes no contraction. This bottom half is for contraction. So for no contractions, we use beta 2 receptors, and for contraction, we use alpha 1 receptors. And all the green stuff is what we're doing to cause this no contraction to happen. All this green stuff on the bottom half is what we do to cause contraction to happen. So yes, it is a lot of information. It is. I recommend rewriting this over and over and over again. You have to memorize this. This is a very common test question. If you know all of these 8 things, wait, 1, 2, 3, 4, 5, 6, 7, 8. If you know all these 8 things, you'll get 100% of this question. And think about this. Just think about this. If you remember all 8 things here, this is probably like 25% of your exam. Okay? You're already 1/4 of the way done. And it's just on this, because there's a lot of questions that can be asked on this. It's actually a big part of smooth muscle contraction. So, if you found this video helpful, please like and subscribe. And until next time, later.